Hey there, everybody. It is time again for Astronomy Daily Live. Hope everybody's doing well. It is 2 hours UTC. Here we are again, gathering together, this circle of friends to, you know, forget about the news and turn off the TV and let's think about the universe for a while. That's, uh, well, it can be overwhelming, but it can also be very, very right. To think about how incredible things are and how insane the universe is. So yeah, I hope everybody's doing well out there. All is well here. Do have another clear night tonight, but I opted to not do any observing tonight. I've got data data that I'm still running through. And before I forget, I'm going to tweet the fact that I am live now. Tweet! Yay. Sometimes I remember. It's amazing. There we go. Very cool. So I've just been watching Skylius's Twitch um, stream for about the past 2 hours, 2 hours or so. I don't know how she keeps it up. It's yeah, that's a very tiring thing. You know, being a just a um, uh, not necessarily a participant, but just sort of an observer. It's very tiring. So yeah, my hats off to anybody that can pull that off for multiple hours. So, yeah, I hope everybody's doing well. Come on in, join the circle of friends as we sit down in sort of the virtual lounge area. I sort of um, see us, gathering together on like an outdoor porch with some comfy chairs and you know a nice drink or other consumable of our choice. I've got uh, I've got some like massive chunks of hair in this. Oh well. Oh well. There we go. I think I got most of it out. It's really it's sometimes important to you know look look in your cup or look in your mug before you actually start uh, filling it. So cheers. This is okay now. Cheers. So this is hydrogen hydroxide tonight. HOH. So yeah, last night's observing session went really well. I had thought that I had captured three binary stars, and turns out that the second one I think I misidentified because I'm I need to compare uh, these binary stars to binary stars that I see in the Gaia catalog. Excuse me, and I'm not seeing the same star patterns. So I think I misidentified one of them. The interesting news, and it's both good news and also sort of head scratching news, is that so I observed three stars last night, and the first one uh, I looked at this afternoon. I actually got an accuracy of about um, uh, like 83 um, millimagnitude, so point 0.083 magnitude difference in terms of um, accuracy, and the precision was around like 60 some millimagnitudes. So it's like this is very cool. This is very cool. right? The problem with that is that all the other data that I've looked at hasn't been that accurate, right? So now the head scratcher is, it's like, why is this so accurate when I've got this other set of data that I just took a few nights ago that's consistently like zero point 0.4 magnitudes off. So why is there, so I'm really pleased that the accuracy is the way that it is, but uh, uh, um, uh, I I don't know why there's that kind of a difference. And yeah, this was uh, this was cleanup day. So yeah, that it's you know um, hair is one of those things that absolutely drives me insane. Um, uh, and but I'm also sort of in certain regimes, I'm extremely lazy. So I let things go and I let things go and I let things go until I just can't stand it anymore. It's like, everything that I'm thinking is about, how terribly annoying, this hair is. So it's like, okay, I've got to do something about this. And I actually stayed home um, today, which is nice. And it's like, okay, I've got this extra time, so I'm gonna take a little bit of time and knock it all down. So yeah. So I'll be good for another few months at least. Cheers. So yeah, the photometric um, uh, 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 problem, I guess, continues because now with this um, with this binary star that I just looked at, the accuracy is like it's about as good as I can uh, sort of expect, right? Um, Probably can get a little bit better, if I massage the data a little bit, but I don't like to do that much. I like the data to sort of um, speak for itself. But yeah, maybe I can take out some um, some things where maybe the seeing wasn't quite as good, or whatever. I'll have to take a closer look. But the second star, binary star, um, as I said, I somehow and at the time when I was out of the scope last night, I pointed it uh, to the coordinates that this binary star um, was supposed to be, and of course it wasn't there because my pointing isn't all that great. So I started my little scan, right? I can sort of scan like this, right? And I found this binary star, um, and my thought was, it's like, okay, well, this might not be the one that I was aiming for, but it is a binary star, so I should be able to see it on Gaia. And so when I did that, though, um, grab grab you know hopefully the sort of a wide field Gaia view, and I'm just not seeing it at all. So at the moment, it's misidentified. Don't know. I'll continue with that. I've got a third binary star that I haven't reduced yet or looked at yet. So I will be doing that probably tomorrow morning. and we'll see how the accuracy there is. And at this point, it's like I have absolutely no idea what it's going to reveal at all. So, yeah, we'll see. Cheers. That's science for you. So let's see. Yeah, as I said, I was watching Skylius's Twitch stream past couple hours or so here. She had on a really, really great guest who I recognize. I think I've seen her before. Emily, I don't remember her last name now, but I think she's like University of Washington. Um, she's studying large stars, big, massive um, stars. I don't know if she's actually studying the stars themselves or if she's just doing modeling. I'll have to. It's easy enough to um, go over to ADS, the astrophysics data um, data system, data server, ADS, and type in her name and pull up all of her publications. So I will definitely have to do that just to sort of see where she's really at. Because these kinds of um, 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 Twitch things, you have to keep pretty light. You can't get too heavy, too deep. Um, Very understandably, that I mean, you don't want to bog anybody down, and you don't want to fly too much over people's heads. So that's why you come here, because if you want things to fly way over your head, then you can come here. If you want to get bogged down in things, yeah, you come here instead. So um, we can go, deep or shallow here. Doesn't really matter at all. So speaking of going very deeply or very shallowly, just wanted to, I just like a minute before the live stream here started, I went over onto archive.org, and I will share my screen here. And I saw this um, interesting article, which I don't know if I've ever uh, seen anything quite like this. Levesque, Emily Levesque. We can actually, well, let me do this, and then uh, let's go over to ADS together and just pull up a list of her papers. Yeah, but look at this. This is very cool. So this is a Type 2 supernova, which is a single star that has exploded, right? A single massive star. But look, um, it was observed within the first day after the explosion. So this is very cool. This is very cool. Um, now I'm not going to dive into this at all. I just wanted to sort of alert you to the fact that a Type 2 supernova has been observed. Probably, it looks like within the first day, and it looks like it had a peak. Um, uh, Now, I want to call that an absolute magnitude. They're calling it M sub V, which I would interpret in a different way, but an absolute magnitude of negative 18.36. That's quite a bit brighter than the moon, not quite as bright as the sun, sort of right in between there. Okay, but this, absolute magnitudes, what is the visual magnitude of an object if it were 10 parsecs away. Okay. Now, if our sun were 10 parsecs away, it would be about fifth magnitude or so. So this supernova is like 23 orders of magnitude brighter than the sun. so, so really, really bright. But it's a supernova, so what do you expect, right? Um, but let's see. As I said, I don't want to get into this too much. Um, uh, but yeah, apparently they think that they saw it from the first day after the explosion up to 120 days. So let's see. Okay, so there's the. Okay, so they've got a pre-explosion. Holy moly! Yeah, they've got a pre-explosion image. Wow, that's awesome. That's very awesome. Um, so that was taken on August 7th, and then on August 8th, they they saw it. So wow, that is lucky, 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 lucky. Levesque. Okay. Thanks. Thanks, Tom. I'm terrible. Um, I like Levesque even more, but okay, if it's Levesque, that's cool. But yeah, so isn't that cool? Isn't that awesome that they actually have a pre-explosion image and a post-explosion image? That I'm telling you, man, that is rare. That is really, really rare to see that. So that is very cool. So then they have the typical light curves and stuff too. So it brightened up after a couple days. That is very awesome. Yeah, that's very, very awesome. That is so cool. Okay, well, this is just an alert. Oh, good. They used IRAF. See, these are smart astronomers. See, smart, good astronomers use IRAF. So, yeah, very good. um, tongue in cheek there, of course. I'm biased. There's some spectroscopy showing how the spectrum changed over days. You can see this big emission line here just sort of appeared over a couple months, just got more and more and more, and it changed shape, it changed width. Oh man. So what is that? Okay. Oh, come on now. Jeez. Give me a break. So that's H alpha. Um, that's a primary hydrogen line. So yeah, very, very cool. So they think that they saw it plus zero point 0.6 days, so a little more than half a day after the the explosion. So very, very cool. And yeah, see, so they're seeing all kinds of stuff in there. So very cool. That's extremely rare. Extremely rare. They were lucky. That's all it is lucky. Now this is going to change after things like um, LSST, the large synoptic survey telescope. I think that's what that's called. Um, so let's see here. Okay, discussion here. We compare our object properties with those of a sample of other well observed. So I guess yeah, this has happened before. I mean, it does happen from time to time. All right. Well, I'm not going to get into this too much because there's a lot of plots and a lot of stuff here. Let's look at the conclusions. In this paper, for the first time, we show photometric spectroscopic data on supernova 2016 ESW, together with a study of its host galaxy, thanks to our rapid follow-up observations from less than 1 day after the explosion up to 120 days later. and to a comparison with other supernova type 2 from the literature, we find a number of interesting similarities. Cool. Is a luminous supernova type 2 with an absolute magnitude between 1779 and 1836. Cool. Interaction also suggested by the early type spectra showing nearly featureless blue continuum. Early type spectra do not exhibit strong high ionization emission lines. During the transition between interacting, exhibit P Cygni profile. Wow, that's very, very cool. Unusually long flat plateau slope relative to its luminosity. It seems not to follow the well-known relation between the luminosity and the plateau decline rate. Early type light curves. That's just awesome. Okay, yeah, I didn't want to hang on to that too much. Hey there, Andy. How's everything over there? Man, it is early in the UK. Thanks for joining. You must be a rebel, or you must be some kind of an astronomer being up at night like this. Maybe you're a vampire, who knows? But cheers. Thanks for coming into the circle of friends here. Just quickly looking at this paper that just came out on archive.org. They observed this galaxy explode less than a day after um, after it exploded. So it's like very cool, very lucky, very, very cool. All right, what I wanted to do tonight is let's do a constellation of the day. And what I like to do with constellations of the day is, look at the constellation itself. I'm sort of the stars that make up, the constellation. But then I like to dive a little bit more and see if there's anything interesting in terms of either stars, binary stars or variable stars, or any of the non-stellar objects that are contained within the boundaries of these constellations, and just sort of do sort of a scratch the surface survey of what's going on inside of these constellations. Well, there's Gilles from Montreal in the chat. Hope everything's well up there in the cold north. So yeah, let's do that. So the International Astronomical Union. Oh, wait. Before we do that, let's go and see what papers Emily Levesque has published. So adsabs.harvard.org. So again, are we not? Let's do it this way. Obviously, that isn't the right link. ADS abstract. There we go. So Emily Levesque was a guest on Skylius's Twitch stream tonight, and she was talking about massive stars. So what I like to do is I like to see what she's really up to by looking at what papers she's recently published. So I'm just going to type in Emily Levesque, and thank you, Tom, for punching in her name into the chat. So again, I'm just going to do this kind of briefly. Nothing so far. Let's do this. Sometimes it doesn't come up at, after their name. It's more like a, E. Levesque. So let's see here. Let's actually do that. That comma E. Whoop. Comma E. Okay, there's one. This might be one too, but it's got like 35 co-authors. So let's just see. So let's see, this one for sure, right? Emily Levesque, stellar and nebular diagnostics in the UV for star-forming galaxies. Okay, interesting. A spatially resolved study of the gamma ray burst 020903 host galaxy. Yeah, she was talking about GRBs, being interested in those kinds of things. Okay, see here she's the primary author. So W first, guest observer science with the coronagraph instrument. The W first isn't even up there yet, so yeah, I'm not quite sure what's going on there. Atomic absorption line diagnostic for the physical properties of red supergiants. Coronagraphic imaging of circumstellar material around evolved massive stars. Mapping the supernova-rich fireworks galaxy. Huh, fireworks galaxy. I never heard of that before. That's I guess it's a AAS publication of some sort. I may not be able to get into that one. Let's see what else she's up to here. More W first stuff. A mote in Andromeda's disk, a periodic active galactic nucleus behind M31. Huh. That's kind of strange and interesting. So she co-authored something called Understanding Stellar Evolution. That's a big subject. Okay, yeah, I think she's an author of some textbooks as well. So my guess is that that's probably what what these things are. It says it's a book. So that's very cool. Written a couple books. Viziar online data catalog. Yeah, I'm aware of Viziar. I've got to get into that a little bit more. For sure. So here's one that says there are supergiants in the sky searching for misidentified massive stars in algorithmically selected quasar catalogs. That is cool. That's very interesting. I'll bet you she's really going to be liking Gaia. Sunshine in Canada, does that happen? I don't know about that. I've never heard of that. Sunshine in Canada? Huh. That that's a novel idea. I highly recommend it, Jill. Symposium summary, blah 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 blah. So here's one that says, I don't know how to pronounce that exactly. Is that 2ZW40 30 Doradus on steroids? The red supergiant content of the local group. Yeah, so I guess 2ZW40 is some kind of super nebula. Yeah, wow. Okay, so here's another one. It looks like it's the same thing. a moat. Didn't we already see that somewhere? Oh, we saw that somewhere already. Yeah, interesting. Here's a paper in 2018 from AAS, and I guess they republished it. That's kind of cool and interesting. Okay, yeah, they published it in AppJ. Um, so yeah, she's doing some pretty cool stuff. It's kind of hard to tell where she is sort of leaning here. Partially because I mean, I certainly don't know that much about all of these kinds of things, but definitely looking at red giants, right? Um, but there's also these AGNs, right? So yeah, I'm not quite sure. Not quite sure what she's up to. Most astronomers have lots of interest. That's sort of a human thing. So yeah, very cool. Okay, yeah, she's a very good speaker. Yeah, very clear. Doesn't really talk too fast. A lot of um, people younger than I seem to talk really fast. And I mean, I know that I'm a victim of that too, but I try to slow down a little bit when I can because Astronomy Daily Live here is supposed to be a very casual, fun um, um, gathering of friends where it's like you know laid back. Just, we don't have to pack a lot of information in. We're not in any kind of hurry. The one thing that I hate, I mean, and there are very few things that I actually hate, but the one thing that I really hate is hurrying. So, talking fast and trying to pack a lot of information in and that kind of stuff. Yeah, that's not my style. My brain just doesn't operate that way. Now, sometimes I can get very excited, and that'll probably make me talk a little bit faster. But yeah, we like to keep it nice and slow here. So, yeah, her enthusiasm is extremely contagious. So, yeah, and as I said, I've seen her before. I recognize the voice. I recognize, the face. I recognize the the passion. And yeah, she can really. I mean, uh, she's a very good speaker. So very nice listening to her, and it was great. I was asking. I try not to be too overwhelming with my questions because once I get going in terms of asking stuff, it's like it's like an avalanche, right? So I mean, I've got to hold back, but I tried not to ask too many questions. But the cool thing is that either she picked up on them or Skylius picked up on every single question I asked. Oh, we have a visitor. We have a visitor. Hello, hello. You're gonna you're gonna come and smash the parade here a little bit. Let's see if I can. I've got wires to deal with here. So here's he doesn't he doesn't want to actually come up here. He wants to settle on my lap, which I'm gonna let him do. So all right, if you think that you can settle on my lap, then I will let you do so. But if you start playing with the wire, you're going to be the flying kitty. Yeah, you're going to be the flying kitty. So yeah, you might see some You might see some ears here. There he is, just poking over the screen. Yeah, I guess he's gonna settle in my lap here. Probably. No, maybe not. Hello. Hello. You're going to settle? Yeah. All my cats are cool. All of them. All right. Let's let's get on with things here. Let's do a constellation of the day. Now, the International Astronomical Union. All right, he jumped down, which I'm actually very very glad that he did. I'm I can be kind of wiggly, so cats don't really last too long in my lap when I'm at the desk here because I'm usually working, and I'm shifting around a lot. All right, so the International Astronomical Union has defined 88 constellations in the entire sky. So that's, you know, southern hemisphere and northern hemisphere. Um, so I have a list, I have an alphabetical list of the constellations, which I now have up on my Linux machine here. And what we're going to do is I'm going to go back over to share my screen. Got to get this hair off my face now. It's shedding season. All right, so I'm going to hide that. Whoop, I'm going to hide that. And go back over here. We're going to go over to random.org. Random.org. And we're going to have this site choose for us the constellation. Come on. God. So there's 88 of them. So I'm going to choose an integer between 1 and 88 randomly. So you ready? Drum roll, please. So number 82. Okay, so I'm going to go to my list here, and I'm going to go to the 82nd one on my list, and that is the constellation of Tucana. 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 Now, I already know that that is a southern hemisphere constellation. But let's check it out. Let's check it out. Because personally, I don't care where these constellations are, where these stars are, where these objects are. They're all incredibly awesome. So I found that Wikipedia usually has the best sort of charts to show where these are in the sky. So there we go. We'll zoom in on that a little bit. Yeah, okay. So here you're seeing along the bottom and probably the top, yeah, is the right ascension, right? And right ascension goes from 0 hours all the way around to 24 hours again, right? And then along the y-axis here, the vertical axis is the declination. So that goes from 0 degrees at the celestial equator to positive 90 in the north and negative 90 in the south. So you can see that this is a very southern constellation, right? We're going between what I want to say like negative 56 is this one down to the extreme over here, which is what, like maybe negative 75 or so. And then it's going from what, like a right ascension, what is that? A right ascension of about 22 hours all the way over to about 1.5 hours or so. And so typically how at least the visible stars are named is that the brightest visible star is called alpha, and then the next brightest one is beta, and then the next one is gamma, and the next, on and on and on. Now, it doesn't always follow that pattern, but it uses, the Greek letters. Now these stars also have numbers. They all, they can be part of other catalogs, so they have other names. If they have a number, it's the numbers of the stars are usually in order of right ascension, going from west to east, right? So this is west, this is east, this is north, this is south, of course. And you can sort of see here's uh, the asterism, right? The star pattern that makes up this constellation, and it also includes these stars down here, and they've highlighted a couple of other objects. Probably those look like globular clusters, so that might be interesting to investigate a little bit. Let's see. So as you may have guessed, the constellation of Tucana is named after the toucan, South American bird. Let's see. So it's one of 12 constellations sort of created. They call it conceived in the 1500s by this dude. So that's kind of interesting. Regular in shape, blah, 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 blah. So what I like to do at this point, well, let's go through the Wikipedia entry and sort of see what it's doing. I guess they can see bright stars down to the letter rho in the Greek alphabet. It's a group of 3 stars, which makes up beta Tucanae. Benjamin Gould designated the star Chi Tucanae. So beta, delta, and kappa are multiple star systems. Beta is actually 6 stars. Delta is 2, kappa is 4, located near the tail of the toucan. So yeah, that's down over here. Let's see. Lambda is an optical double, but yeah, they're not actually a binary system in any sense. Okay, most of the small Magellanic Cloud lies within the constellation of Tucana. Oh, that's kind of cool. Okay. Didn't know that. That's cool. Let's see. Epsilon is a B-type subgiant star. So that's a B star. It's a big blue star. B94, it says. Apparent magnitude of 4.49. So we can see that with our naked eye in a dark sky. HIP is lurking. Thank you for lurking. HIP. Let's see. Epsilon Theta is an A-type star, which is just a little bit hotter than our sun. Our sun is a G-type star. 423 light years. It's actually a close binary system. The primary star is also a variable star. So that's kind of cool. Zeta is a yellow-white main sequence star. F, so it's a little bit cooler than our sun. 28 light years away, so that's pretty close. but it's more luminous than the sun. So yeah, that just means it's evolved a little bit different. So it says that 5 star systems have found to have planets, 4 of which have been discovered by this instrument called HARPS, which looks at the radial velocity of the star, and notice that is changing over time. So, by a certain amount. And I guess they've probably determined that the amount that the radial velocity changes sort of coincides with what would be planets of certain masses. So that's pretty cool. HD 4308 is a star that has a super Earth planet of an orbital period of about 15 days. Also, a super Earth orbiting every 3 days. That's just kind of crazy. Okay, of course, 47 Tucana is a huge, beautiful globular cluster. It's actually it's the second brightest glob after Omega Centauri. By the way, I can see Omega Centauri from my latitude here certain times of the year, and it is that time of year right now. So last night, while I was collecting data through my scope, I pulled out a pair of binoculars and actually looked at Omega Centauri last night, and it's very awesome, very awesome. But yeah, 47 Tuk is down there, obviously in the constellation of Tucana, just west of the small Magellanic Cloud. It's pretty close, right? 14,700 light years away. Blah 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 blah. So NGC 362 is also there. So that's pretty cool. Let's see, the small Magellanic Cloud, of course. There's a open cluster, NGC 299, also in the constellation of Tucana. Looks like there's a galaxy, obviously behind all of these, all these things. So, wow, where should we go from here? See, this is sort of a jumping off point. It's a jumping off point. Now, 47 Tucana is pretty popular. So, let's stay away from that. I'm sort of wondering. I really didn't see any variable stars listed here. So what I'm going to do is I'm going to stop sharing for a minute here, and I'm going to go to my Burnham's Celestial Handbooks and pull up probably what's going to be volume 3. Volume 3, yeah. Volume 3. Now, I've had these books for probably about 35 years, maybe even more. So this one doesn't have any cover at all. It's got a big, hopefully, I think that's a coffee stain. No back to it, no side, no cover at all. But it's a 3-volume set, right? 3-volume set organized by constellation. So it also does an alphabetical list of constellations. So I know that volume 3 is going to have Tucana in it. So let's just see what kind of variable stars are in Tucana, because what Burnham's does, among lots of other things, right, is that I've got some wrestling kitties over here. They probably want out. I am just a servant, so I have to be doorman. So Burnham's lists a bunch of binary stars in the constellation of Tucana. It goes on for not too long here. Let me get to the right page. Come on. Okay, so here's the rest of the binary stars. And then down on the bottom is a list of variable stars. So there's a few variable stars. And then over here are all the extrasolar objects. And you can see there's a couple of globulars, yeah, and there's a few galaxies. So let me look at the variable star list here and see if there's anything interesting. So theta Tucanae is a variable star. And then, yeah, there's just a few others. Long period variables. There's an eclipsing binary star. So, yeah, not too interesting. I'm sort of inclined, I don't really lean towards the underdogs, but and this actually wasn't this open cluster, this NGC 299. I'm going to look over here again. I'm not sure if 299 is within Tucana or not, because Burnham's would list that. Let me go back to Burnham's. Arg, 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 arg. Let me get my screen back here. So let me go back to Burnham's really quick. Go back to Tucana. And okay, so they're only talking about NGC 104 and NGC 362 as the globular clusters. But for some reason, Wikipedia is also talking about NGC 121. And I know that you're not seeing this screen. Near 47 Tucana in the sky, and often seen in wide field photographs showing it, are two much more distant globular clusters associated with the Small Magellanic Cloud, NGC 121 and Lindsay 8. So, well, let's look at NGC 299, huh? Let's look at NGC 299, and I like to sort of dive into these and see if there's anything interesting about these particular objects. This is an open cluster, which usually means just a few stars, but they probably all formed at the same time, but they are different masses. So the idea is that because they're different masses, they're going to be evolving differently. And so you'll get yellow stars and blue stars and red stars and white stars and just a rainbow, right? So let's look at NGC 299. So I'm going to share my screen here. Dun, 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 dun. Share my screen. And then let's go over to NGC 299 real quick like. Not incredibly quick, but let's go over to Simbad, the astronomical database. And let's type in NGC 299 and just see what comes up here. Cluster of stars, yes, for sure. So that the Digital Sky Survey doesn't really do it justice. Let's see if the Sloan Digital Sky Survey does it any better justice. The Sloan Digital Sky Survey actually may not have that as part of its thing because it's so far south. Yeah, it's probably too far south. Anyway, so yeah, we can see that it's yeah, it looks like it's definitely in the constellation of Tucana, right? Yeah, I think those, I think that falls in there. Pretty faint though, right? These are the U, B, and V magnitudes. These are sort of um, visual um, magnitudes, slightly different filters, right? The U is sort of violet, the B is blue, and the V is sort of towards the green. I is leaning towards the infrared. So you can see, I mean, pretty faint, right? Pretty faint. We we can see with our own eyes down to about sixth magnitude under really, 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 really dark skies. So the fact that these are, you know, six magnitudes fainter than that, it's pretty faint, right? Pretty faint. Whoop, that's doing that. But it again, you know, it does look like it gets brighter as we move towards the infrared. So that's pretty cool. Here's a few other names for it. Prawn 32. That's a cool name. Lindsay 49. So there are a few references. So yeah, well, okay, we can dive into that a little bit more. Oh yeah, but that's it. Wow, that's all there is. There's not even like a distance measurement or anything. Oh wow. Okay, well, let's quickly take a look at the picture. We know that this is going to be part of the Small Magellanic Cloud. So we're going to see a shitload of stars. I'll zoom out a little bit here. It's going to get lost. It's going to get totally lost because we're looking right in the Small Magellanic Cloud. See, I'll zoom way out here soon so we can see the whole cloud. Okay, the SMC is way over there. Still, we're looking in a you know very, very, very rich area of the sky. Actually, this is part of the SMC. Yeah. Wow. So you can see 47 Tucana over here, right? There it is. But that's where NGC 299 is. Poor little NGC 299. Here's another globular up here. Yeah, just massive amount of stars. Look at all that. That's insanity. That's insanity. And you know, think about it, right? Think about this idea that every every one of these stars are individuals, right? They're individual stars, probably having individual planets and individual people, right? It's just awesome. Very, very awesome to think of just the numbers involved here, right? It's just crazy. Crazy, crazy. All right, let's go back and look at some papers that supposedly reference NGC 299. Let's see if they actually do. The insidious boosting of thermally pulsating asymptotic giant branch stars in intermediate age Magellanic Cloud clusters. Oh, look at this. Photometric analysis of variable stars in NGC 299. How cool is that? So everything else is talking about NGC 330, which must be nearby. So Magellanic Cloud stellar clusters, they actually have color magnitude diagrams for six large Magellanic Cloud and 10 small Magellanic Cloud clusters. Don't know if they're talking about 299 or not, but this paper is specifically talking about NGC 299. So probably not a lot of info there, but yeah, pretty recent, 2013. Let's take a look. So we've okay. Let's go to the ADS. grab the actual paper if we can. Yes. I love looking at papers. So photometric analysis of variable stars in NGC 299. Oh, so one of these authors lives just up the street, sort of, from me, over in Tempe, Arizona, which is well, at least the same state. I've still got some wrestling some wrestling kiddies over here. They sure have a lot of fun. So NGC 299 is a young and relatively small star cluster in the Small Magellanic Cloud. It's classified as a Type 1 um, cluster. Um, based on the brightness of the upper main Huygens termination point, estimated cluster age to be 15 to 20 million years. So pretty young, pretty young. Um, and they might be helium burning giants. So yeah, the only way that you can have something that young and already being burning, that is fusing helium, is if they're pretty massive. At least that's how the story goes. Um, Photometric survey calculated integrated colors. These kiddies are really getting violent. I think I'm going to let them out. Hold on one second. Hold on. Okay, my doorman duties are over. So yeah, I guess these guys found it to be between 28 and 100 million years. These guys found it to be 25 million years. These guys found it to be about 25 million. Um, let's see. This behavior is most pronounced for BE stars. Blah 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 blah. Talking about NGC 330. Although no comprehensive spectroscopic study of NGC 299 has been undertaken, uh, these authors investigated 4 stars that might be cluster members. Uh, and they were found to be evolved B-type stars. So again, a B star is a very very massive hot star, evolving very quickly. So we're seeing it sort of early in its life, which makes sense if this cluster is relatively young, right? Okay, so whatever Ogla 3 is, that's some kind of instrument or telescope. Um, Geometry maps. Okay, well, there's going to be pictures. Yay! It's always nice to have pictures. But see how, I mean, every single paper is like a jumping off point. I mean, I could be like, what is Ogla 3? What is that? And I could go off on that um, tangent, right? All these references not only sort of talk about the topic, but are also sort of a history lesson, right? So any of these papers is just really really cool if you want to learn more and more and more and more and more, not only about the subject matter itself, but also the history of the subject matter. So that's why I think these papers are great. Let's see, color magnitude diagram. Okay, cool. We're going to get into all that. Many stars fainter than 18 and a half have a larger than expected photometric dispersion, blah, 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 blah. Shown in figure 4, we note that no short period pulsating variables are present in NGC 299. So we're looking at sort of long period variable stars. I guess they found 3 of them. 3 of them. Okay, that's a relatively short period, right? 1.59 days, 14.74 days. Let's see, they don't talk about. I guess they're not talking about what the variability is here, just what the period is. Based on brightness and its proximity to the cluster center, the star is likely to be a cluster member. So the large amplitude, so 350 millimagnitudes, long duration, 3 years. Okay, this star, okay, so the next one here lies outside of the main body of the cluster, but they still think that it is. So yeah, this is probably some kind of a eclipsing binary, but it's like 90 millimagnitudes, which is or actually what 120, yeah, 120 millimagnitudes. So yeah, not a huge amplitude in terms of variability, but it's there. So yeah, they're not quite sure about the membership of this last one. It lies what I would guess to be just sort of on the edge of the cluster. It looks like it's also an eclipsing binary star with a period of 14.74 days. And yeah, it's not even giving an amplitude there. Okay. Let's see. The brightest stars in the direction of 299 have been observed by 2 mass, consistent with red supergiants. Huh. Okay. All right. There we go. So there's a picture. We finally get to see a picture of NGC 299. All right. Yay. So here's, see. Okay. So this, I sort of would say, they're sort of defining as the halfway point out. That's what FWHM means, full width half maximum. And then yeah, here's sort of the another edge, and then this I would guess they're probably saying is sort of the extreme edge. That's 100 arc seconds on a side, which I'm going to grab my handy dandy calculator here. 100 divided by 60, so that's like 1.7 arc minutes. So yeah, it's very small, very small. But there's definitely a clustering there, right? But wow, these are just really faint, really faint stars. Looks like there's 3 primary ones. I don't know why some of these are excluded, not quite sure, but I guess these are the ones that they looked at. Have to actually read the paper in order to find that out. Here's a color magnitude diagram. So this is the color. So they're just taking the V magnitude and subtracting it from the I magnitude. Those are two different filters. And then they're comparing that to the I magnitude. And so you get these distributions. You know, they tend to clump and have these shapes to them like that. Box outlines that portion of the diagram which is hot. Pulsating variables are likely to be found. Okay, so yeah, the pluses are within that inner radius. So yeah, there's quite a distribution of stars here. Okay, interesting. Um, you know, I don't know what sigma I stands for. Guess I could look it up, but I'm not going to because I'm running over time here. Don't want to take too long. So here we go. Here's the variability themselves. So of these three stars, right? So the top one is number 11727, and yeah, it looks like it just sort of did its thing once, right? I mean, it got a little bright, but you can't really determine what the periodicity there is because we're not seeing it. Here we're definitely seeing a periodicity, but you see how these go fainter than this one. So yeah, that's probably caused by the eclipse. These these two are probably when the secondary star is passing in front of the primary star, and this is when the secondary star is passing behind the primary star. So you don't get quite as deep of an eclipse there. And yeah, maybe we're seeing the same thing here. Kind of hard to tell. Kind of hard to tell. And that's it. That's it. So they were just looking at a few stars in NGC 299. I don't think they talked about how far away it is or anything like that, how old it is. Did they say anything about how far away? Just how old it is. Yeah, I don't really see anything about distances or anything like that. All right, well, cool. So anyway, there's at least one of the little studied objects inside of the constellation of Tucana, which is a southern hemisphere constellation. So for all you northerners, including me, I ain't seeing that thing. I probably never will. Hopefully someday I'll get the opportunity to travel a little bit south because I would definitely like to see the large and small Magellanic clouds for sure. And when I do, I now know that when I'm looking at the small Magellanic Cloud, I'm at least looking in the direction of Tucana. So yeah, very, very cool. All right. I think I'm going to get out of here for tonight. Um, yeah, hope everybody has a great evening, great day tomorrow. I will see you on the spin tomorrow. Don't get dizzy. It's all right. It's a smooth ride. But I will see you again in a little less than 23 hours. All right. Take care, everybody. Bye.